Good morning, sir. Myself and Devi. I am from EC. My roll number is 2340 and today my topic is I2C protocol. First, we can go through the introduction. Introduction to I2C. I2C stands for Inter-Integrated Circuit, a popular serial communication protocol. It was developed by Philips for easy communication between ICs. I2C used only two lines, SDA and SCL, for data transfer. It follows a master slave communication structure where the master controls the clock. Multiple devices can be connected on the same bus using unique address. It supports different speed modes like standard, fast, and high speed. I2C is mainly used for short distance communication on a single circuit board. Common applications include sensors, EEPROMs, RTCS, and display modules. Next, features of I2C. The features of I2C are two-wire serial communication, supports multiple master and slaves, use 7-bit or 10-bit addressing, synchronous data transfer, bidirectional data line, variable speed modes, acknowledgement after each byte, and clock stretching support, simple and cost effective bus design suitable for short distance communication between ICs. I2C bus architecture. In I2C bus architecture, we can see two-wire bus, master slave configuration, open drain lines, clock control, addressing system, bidirectional data line, and acknowledgement signal and multi master support. This is the bus configuration. Next, we can go through the working principle. Master generates a start condition to begin communication. Master sends the slave address with a read or write bit. Slave sends a acknowledgement if it is ready. Data transfer occurs byte by byte, synchronized with the SCL clock. Receivers send acknowledgement after each byte. Master generates a stop condition to the end communication. Multi-master arbitration prevents bus conflicts. Slaves can use clock stretching to delay communication if needed. Addressing in I2C. Unique addressing. Each device on I2C bus must have a unique address to avoid conflicts. 7-bit and 10-bit addresses. 7-bit and 10-bit addresses. Standard I2C uses 7-bit address while extend addressing uses 10 bits. Address format. The 7-bit address is followed by a read or write bit, making the transmitted byte of 8 bits. Master initiate communication. The master device sends the address of the target slave to initiate communication. Acknowledgement. After the address is signed, the slave responds with an acknowledgement if it is recognized the address or not acknowledgement if not. Reserved address. Some address are reserved for special functions and cannot be used for normal devices. Multiple devices. Addressing allows multiple slave devices to share the same bus without interference. Advantages of I2C protocol. Simple two-wire inference. Support multiple master and slave devices on the same bus. Each device has a unique address to avoid conflicts. Flexible data rates. Standard, fast, and high-speed modes. Requires fewer microcontroller pins compared to parallel communication. Allows bidirectional communication. Synchronous communication ensures data is synchronized. Simple hardware requirements. No need for separate chip. Select lines. Widely supported by many sensors and peripherals. Efficient for short distance communication on a PCB. Next, limitations of I2C protocol. The limitations of I2C protocol are short distance communication, limited speed, bus congestion, complexity with multiple masters, pull up resistor required, limited data size, per transfer, noise sensitivity, address limitations. Applications of I2C: real-time clocks, EEPROM communications, sensors inferencing, LCD or OLED displays, digital to analog converters and analog to digital converters, microcontroller to microcontroller communications. Conclusion: I2C is a simple, efficient and widely used communication protocol for connecting multiple ICs with just two lines. It supports both master and multiple slaves devices, making it versatile for various applications. The protocol allows the protocol allows easy addressing and reliable data transfer between components. It low pin counts, reduces circuit complexity and saves PCB space. I2C is ideal for short distance on board communication in embedded system. Overall, I2C is cost effective, flexible and essential for modern electronic devices. Thank you, sir.